So today is lesson 15. We're gonna be solving word problems today. Our favorite. Yay? Yes, Zoe? Yes? We're into it? Yeah, okay, good. Okay, so we're basically gonna build on the skills that we have learned to continue to solve multi-step word problems this time. So you know how yesterday we had fractions that we were adding and subtracting at the same time? Today we're gonna do the same thing, but they're gonna give us a word problem. Sound good? Okay. So our learning goal today is I will be able to strategize on how to solve multi-step word problems involving fractions. How we're connecting to prior knowledge is we're going to continue to build on our knowledge of adding and subtracting fractions with uncommon denominators and be able to solve multi-step word problems. Okay? Yeah? We're good? Any questions before we move on? No? Okay. So some of the steps we're going to take is we're going to create an expression that is representative of the word problem, right? We're going to add or subtract common fractions. We'll create equivalent fractions as needed, and then we'll solve. Yeah? Good? Okay. Problem 1. We're going to do the RDW strategy, so can somebody tell me what RDW stands for? Raise your hand. Juan. What does it stand for? Yeah. What's the R and RDW stand for?
V.
Okay. And the D?
Draw.
And W?
Right.
Okay. So we're going to read the problem. We're going to draw a picture that's representative of the problem. And then we're going to write an expression. And then we're going to solve. Yes? Okay. So let's read this together. In a race, the second place finisher crossed the line 1 1/3 minutes after the winner. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the winner take? Okay, so what do we know? What do we know first? Sean?
The second place finisher crossed the finish line 1 1
Okay, good. So we know that we have 3 racers, right? So we have 3 racers. So we have the first, we have the second, and we have the third, right? And like Sean said, the second place finisher crossed the line how much after the first place? How much after the first place, Sean? Did you say?
1 1
So the second place was the first place time plus 1 1/3 minutes after, right? What about the third place winner? What did they tell us about the third place winner? Christopher.
He took 31. Oh, the third place finisher took 34.
Yes. So 34 2/3 minutes, right? So that was his total time, right? And what do we know? What else did they tell us? So they told us that the second place winner was this much behind. We know the third place time. But what about this number? Why is this number important? Juan?
Because it was maybe it was the one who.
Take a second. Go ahead, try.
Because it was the first one who.
Try again. Try again. So this time is representative of what?
The first.
The second place, right? So this is the difference from here to here, right? Okay. Good. So then now, what are they asking us to find?
The winner.
So they want us to find the first place time, right? So this is what we're finding here. We're finding the first place time, right? Okay. So then, in order to find the first place time, I need to first figure out what the second place time was, right? So then, how do I find that? What kind of expression can I write? Yes, Dominic.
So expression.
Yeah, like what kind of how would my expression look to find the second place time?
Oh. I thought what we had to do.
Okay, tell me what do we have to do?
So I think we have to do how long the third place took.
So we know that, right? How much is that?
34 2/3.
Okay, good. So 34 2/3. Now, how do I find the second place time?
By subtracting 1 and 3/4, I think.
Good. Okay.
Which would give us what the second place took.
And this is equal to what?
What the second place. How long the second place took.
Good. Good. So, so what's my LCM here?
12.
So my LCM is 12.
What
Right.
What's
Our least common multiple
Oh.
between these fractions, right? So then we know what? That 34 and 2/3 is equivalent to something over 12, right? 3 times what gets me to 12?
10.
And whatever I'm doing to the denominator, I'm doing to the.
Numerator. 8.
So 2 times 4 is?
8.
Okay, so then my new equation here is 34 and 8/12. What about for 1 and 3/4?
3.
Is equivalent to something over 12, and I'm
Right.
multiplying by what, Uriah?
3.
So 4 times 3, whatever I'm doing to the denominator, I'm doing to the.
Numerator.
And 3 times 3 is?
9.
Okay, good. Minus 1 and 9/12. That's gonna give me second place. So then here, how do I do this? Can I subtract 8/12 from 9/12?
No, you're gonna have to borrow.
Good. So then this splits up, right? And this turns into 33 and 12/12, 8/12, right? Minus 1 and 9/12. Yeah? We're following? Okay, so then this is 33, and what does this add up to? 20/12, good, 20/12 minus 1 and 9/12. It's equivalent to what? So now what? How do I solve? What do I solve with the
33 and 11/12.
30 what?
3?
33?
I know,
Or
32.
subtracted?
32.
So is this what we're trying to find? Is this the answer that, is this what they're the problem is asking us for?
No.
So this is just what?
Second place.
So that we know now that this was equal to 32 and 11/12. Yes? Now, what do I need to do in order to find what the first place winner's time was? With all the
Subtract the answer that we just got by 1 and 1/3.
good. So it is, so then 32 and 11/12 minus 1 and what, Dominic?
And 1/3.
Is equivalent to what? First place?
Yes. The first place winner.
Okay. Yes? So what's my least common multiple for these fractions?
36.
So then do I need to convert this one?
No.
Okay, so then what about 1 and 1/3 is
Times 4.
equivalent to something over 12.
Times 4.
Whatever I'm doing to the denominator, I'm doing to the?
Numerator.
1 times 4 is?
4.
So then this is gonna be 32 and 11/12 minus 1 and 4/12, right? Good. What's my, how do I subtract this?
You subtract the whole square.
Okay, so what's my new whole number?
91.
And what about my fractions?
7.
Good.
7 on the 31. 7.
So this is the time. So we would write the first place time winner's time was 31 and 7/12 minutes. Yes? Are we following? So you see how we have to just take the information we were given, make ourselves like a chart or a picture so that we can visualize what they're giving us, and then apply it to what we need to know, right? So we had to do this step to get to this step, right? Yes? We're good? Okay. Everybody have this down?
Yes.
Okay. Problem 2. So we're doing read, draw, write, right? So John used 1 3/4 kilogram of salt to melt the ice on his sidewalk. He then used another 3 4/5 kilogram on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? Okay, so what do we know? What's the first thing they tell us?
Now,
Jose, what do they tell us?
That John used 1 3/4 kilograms of salt.
So let's draw a picture, right? So 1 3/4 was used for what?
To melt ice.
But melt the ice on what?
The sidewalk.
On the sidewalk, right? So this is for the sidewalk. What else do we know? Juan, sorry.
She used another 3, on the driveway.
Okay, good. So we used 3 4/5 on the driveway. Good. What else do we know?
and he had 10 kilograms of
Of salt, right? So we know that this is supposed to equal 10, right? So there's also another piece here missing, and this is representative of what?
How much is that?
How much is left? So this is the leftover. Yes? Okay. So now, what kind of expression can I write that's representative of this? Yes, Jose.
10 minus 1 3/4 minus.
No, but representative of this. So if I know that all of this adds up to what?
10.
Okay, so then draw me an expression that's representative of that. I know where you're going. Your other expression is not wrong either. So you were saying to start at 10 minus, right?
Yeah.
Okay, but do it with an addition expression. Show me that. Hold on. Tell me.
Add 3/4
Okay.
plus 1 3/4.
Plus 1 3/4, okay. Plus what? Plus something else, right? Is equal to what?
10.
Good. And Jose is saying that we can do this a different way, right? How else can we do it, Jose?
We did 10 minus 1 3/4 minus 3/4.
Right? And then we're finding the part. Yes? Do we see that? They're both gonna give us the same answer, right? They're both gonna represent the problem the exact same way. Right? And this is what we learned yesterday, right? When we rearranged the expression to represent what we were trying to find. Yes? Okay, so let's do it this way first. 3 4/5. What's my my LCM here?
20.
Okay, so my LCM is 20, right? So 3 4/5 is equivalent to something over 20
Times
4. Whatever I'm doing to the denominator, I'm doing to the
Numerator.
So 3 16/20 plus, and now 1 3/4 20th is equal to something over 20. 4 times what gets me to 20? Whatever I'm doing to the denominator, I'm doing to the
Numerator. 15.
good. So 1 15/20 plus something else is gonna get me to 10. Yes?
4 and 1/20.
So what is this get me?
4 and 1/20.
No. Check your math. What are my whole numbers? What am I adding with my whole numbers?
20.
My whole numbers are what?
3. 3
And so what does that give me?
4.
And what about my fractions? 16 plus 15 is what?
31. But that's gonna equal whole.
So then, how many wholes are in this improper fraction?
4.
Wait, no,
5.
5.
No, in
Wait,
this
no, you
fraction.
can't put a number.
I can, right?
Yeah, you can.
So then what is it? 5 and what?
5 and 20. 11. Yes, 11.
Yeah, it's 5 and
Okay, good. But I still don't know what this is here, right? So what do I do?
Subtract it.
subtract.
So then now I rearrange it, right?
Yes.
So what's my new expression, Aiden? What's my new expression gonna be? If I have to rearrange this to find this.
10 minus 5 and 11.
Good. 10 minus 5 and 11/20. Can I subtract this way? I have to borrow it. Good. So then this breaks down into 9. And this is 20/20 minus 5 and 11/20, right? I subtract my whole numbers, it's what?
4.
And then 20/20 minus 11/20 is?
9.
Good. So then we can say that John had 4 and 9/20 salt left over. Yes? Yeah? Good. Do we have any questions so far? Why do we have to rearrange the expression at the end?
Because we added all the other numbers that we couldn't do anything else about it, so we had to switch it up and make it how it was supposed to equal.
Okay. Anybody else? Wanna add anything? No? Okay. Jose, read number 3 for us.
Sinister Sand sold 3 ounces of slime from Messy Molly. But Evil Slime requires 6 3/8 ounces of slime. He stole another 2 3/5 ounces of slime from Rudolph. How much more slime does Sinister Sand need for his evil plan?
Okay. So first let's draw a picture. What do we know?
That he stole
3 and 3/4 of
Messy Molly.
So we know that he
Messy.
had 3 3/4 from Messy Molly. Right? And then what else do we know? Zoe, what else do we know? What else do they tell us? What else do they tell us? How much did he take? How much more did he take? From who? Good. 2 3/5 from Rudolph. Caesar.
Yeah.
How much did he need total?
6 and 3/8.
Okay. And what are we trying to find, Caesar?
How much more he needs?
So we need another box right here. This is what he still needs. And you said we needed 6 and 3/8? Good. Okay. Victoria, how would I create an expression to represent this picture here?
You have to find out how much he needs, right?
Yeah, we have to find out how much more slime Sinister Stan needs for his. But what kind of expression can I write? Okay. So what would I be adding?
3 and 3/4
Okay, 3 and 3/4.
plus 2 and 2/5,
Okay.
and then plus the number that we don't know
Okay.
equals 6 and 3.
Good. 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 Yes, Damien.
You find the least common multiple.
Okay, and what's my least common multiple, Damien?
20.
Okay, so then I know that 3 and 3/4 is equivalent to something over 28. 4 times what gets me to 20?
5.
Whatever I'm doing to the denominator, I'm doing to the?
Numerator.
3 times 5 is?
15.
Good. So 3 and 15/20 plus 2 and 3/5 is equivalent to something over 20. 20. 5 times 4. Whatever I do to the denominator, I'm doing to the numerator. That's what? 3 times 4 is?
12, 20.
Good. So then that's 2 and 12/20 plus the amount that he still needs, and then 6 and 3 is equal to 6 and 3/8. Yes?
No.
So how do I add this?
You had the holes first.
Okay, so what is my new whole number?
5.
Good. And my fractions, what do they add up to? What do they add up to? Before 27.
27.
We need to subtract them.
Can I?
Yes, you can.
What is
6
it?
and 7/20.
Good.
Then once you get that.
Okay. I still need this, right? So what do I have to do now? Yes, Aiden. Tell me. Subtract. Good. So what's my new expression gonna look like?
6 and 3/8 minus 6 and 7/20. Don't you have to find
Yes. So what's my new LCM? Between these 40, that's right. So then my new LCM for my new expression is 40, right? So I know that 6 and 3/8 is equivalent to 6 and something over 40. 8 times what gets me to 40?
5.
Whatever I'm doing to the denominator, I'm doing to the
Numerator.
So 6 and 15/40 minus 6 and 7/20, right? So then here, what do I get? Is equal to 6 and 20. No, sorry, 8 and no 20 times what gets me to 40? Sorry. Whatever I'm doing to the denominator, I'm doing to the numerator. So that's what? Okay, good. So this is 6 and 14/40 is equivalent to what Sinister Stan still needs. So then, what is? How do I subtract this?
Subtract them.
Okay.
0 and then you go. Subtract the fraction.
Now, what about my fractions? Is what?
140.
Good. So we would write Sinister Stan still needs 1/40 slime for his evil plan. Any questions? How do you guys feel? Yeah? Why? Why, Jose? Do you understand it? Where are you lost?
On how
Is it because you would set this expression up different?
rational,
Huh? How else would you set it up?
like the whole thing to like another way.
Oh, yeah. How else would you set it up? Is that because it makes more sense in your head?
Yeah.
Okay, tell me how you would set up.
So like how he requires 68, I'll do 68 minus 3/4 minus 2/3.
That's exactly right. You could definitely do it that way. Yes. You could definitely do it that way. You want to do the next one like that? Yeah? You could do the next one that way. Okay? Sound good? Any other questions? Any other questions, guys? You're right, your hood. Alrighty. Ready? Damien, read number 4 first.
Gavin had 20 minutes to do a 3-problem quiz. He spent 9 3/4 minutes on problem 1 and 3/4 minutes on problem 2. How much time did he have left for problem 3? Write the answer in minutes and seconds.
Okay, good. So, what do we know? Tell me first what we know, Sean.
That Galvin had 20 minutes to do a 3-problem test.
Okay, good. So the total time was 20 minutes, right? What else do we know? Yes, Damien.
He spent 9 3/4 minutes on problem 1.
So problem 1. 9 3/4 minutes. Yes? What else do we know? Juan.
He spent 3 and 4/5 minutes on problem 2.
Good. Problem 2 was 3 4/5 minutes. Okay? And how much time did he have left? And what are we trying to find, Sean?
How much time he had left for problem 2?
Okay, good. Good. Yes.
When we do 20 minus 9/3 minus 3/4 and then minus problem 3.
Think about it again. Say it again. So what are you saying? Telling me to do?
20 the total time minus
Okay.
9/3
9 3/4.
minus problem 2 then minus problem 3.
But what are we trying to find, Damien?
Oh, how much?
So then do we minus problem 3?
No.
So then we would equal, right?
I feel like
The
we have
total.
to.
That make more sense? Yes? Okay. Yes, Sean.
Wait, can't we add problem 1 to problem 2 again and we just see what's left? Would be for problem 3.
Absolutely. And that would equal to what, Sean?
The answer.
No, what would this equal to? Because this is what you're telling me to do, right?
20 minutes.
What would it equal to, Sean?
How much
the total time, right?
Yeah,
Which is what?
20 minutes.
Okay. Both of these setups are exactly right. Do what works for you.
Do we have to do both of them?
No, we don't have to do both of them. Do what works for you. How about let's take a minute and you guys can work with your partners on this one, yeah? Work with your partner. Sean, you can work with either Andre, I'm gonna have you work with Thomas, and then Caesar, I'll have you work with Aiden, and then Sean, go ahead and gather up with these ladies here. Okay? So work it out whichever way works better for you, okay? And I'll come around. We'll have about 1 minute or two. Where do I lose you? The denominators. Wait, so, in the curse stop. We have it in the modules. Set it up. Okay, so what do they tell us first? What do we know based on the problems? You know.
Yeah, but look, we have the other, we have person 1.
Yeah, so we know that that's not what we're trying to do. And what are we trying to find? So then, when we're trying to find them, what else is what other information for us to be able to find them?
Did you get the question?
Reports. Minutes?
Right, 6 minutes. 6 and 9 I said 6 and 9
Okay. So then we know that we have 2 of the times that we use for problem 2, right? From items 1 and 2. And we're trying to find problem 3. So that we can set it up either one of those ways. Does that make sense? Now that you look at it. Because you see how we wrote down all the time that we had? And then we can create an equation that's representative of our problems. Yeah, you understand? Kind of? Not too much. Okay. All right. Okay. How are we doing? Yeah, are we done?
Yeah.
No? Okay, 1 more minute.
So do you need a break? Do you need a break? What did you do for subtract? Did you get 13 and 11 minutes? Subtract that from 20.
So 7 and 11.
Huh?
Oh,
That's a check. I can read 13 chapter books in a day.
Alrighty. Are we ready?
yes.
Okay, raise your hand if you solved it this way. Raise your hand if you solved it this way. This way, you do it this way?
Oh, no, I did it.
Raise your hand if you solved it this way. Okay, good. So, should we go through both ways? Okay. So let's start with, which one do you want to start with? Subtracting?
No.
Okay, let's subtract first. Who did it this way? Raise your hand again. Okay. Jose, what do I do first here?
Or find your least common denominator.
Okay, so what's my LCM?
20.
Okay, good. So that is 9 3/4 is equivalent to something over 20. 4 times what gets me to 20, Christopher?
5.
Good. And whatever I'm doing to the denominator, I'm doing to the numerator. What about this one? 3 4/5 is equivalent to something over 20. 5 times what gets me to 20?
16.
Okay,
5
good.
times 4.
And then whatever I'm doing to the denominator, I'm doing to the
Numerator.
4 times 4 is?
16.
So that is 3 16/20. What do I do next? What do I do next? Christopher, tell me.
Oh, I added both of them together.
You added both of these together?
Yeah.
But we're subtracting here. So you did it a different way?
No, like it's kind of different. Like I added both of them, and I subtracted 20 with the answer I got.
Okay. So how did you do it, Damien?
We borrowed from the 9, 15, 20,
Okay.
and then we subtracted that by 3, 16.
So you did this. So you went 20 minus 8 20/20 plus 15/20 minus 3 16/20. Yeah? You had 35/20 here?
Okay, 20 is
Okay. So then what did you get? What did you do after that? Yes, sir.
We subtracted the whole squares,
Okay.
and then we subtracted the.
And what did that give you?
19. Oh no, the one on it? Oh, 5.
And what about here?
19, 20.
Did we all get that answer?
No.
No. No.
I don't get
Okay. So which other way? So where did we go wrong? Jose, what did you do?
I didn't get that.
Okay. So let's do it again. Let's start over. Right?
Yes.
So we know that when we create equivalent fractions, it's 20 minus 9 and 15/20ths, right? We know that already. Minus 3 and 16/20ths is gonna give us the total for problem 3, right? Okay. The way we solve, yes, Junior.
So on 9, 3, 4 and 3, 4, 5, the denominator, do we like times it?
Yeah, you gotta get to.
You gotta create equivalent fractions with common denominators. So that's why we times it here.
Oh, okay.
Yes. Okay? So we know. So, sorry, let's start again. So when we are subtracting, we have to start in pieces, right? So let's start on this side first. So 20, let's start here. Maybe this will help. 20 minus 9 and 15/20ths. Can I subtract that this way? Okay. So then that's gonna give me 19 and 20/20ths, right? Minus 9 and 15/20ths, minus 3 and 16/20ths, right? But I'm first doing this part here, right? So what does this give me? 19 and 20/20ths minus 9 and 15/20ths. What is it?
10 and 5/20.
10 and 5/20.
10 would be the one.
Good. Minus 3 and 16/20ths. Yes? Okay. Now, can I subtract?
No.
So what do I have to do again?
Borrow.
Okay, good. So that's 9 and what? 20/20ths and 5/20ths, right? Minus 3 and 16/20ths, which is equivalent to 9 and 25/20ths minus 3 and 16/20ths. So what's my answer?
9.
What is it? 6 and what?
6 and 9 20.
5
and 9. It's not 5.
6, 9,
Yeah.
That's the right answer. That's the right answer.
Is that right?
Yeah.
Yeah.
Okay. Yes. Okay. Now, what if I was solving it this way? What if I was solving it the addition way? So we have 9 and 3/4, right? Plus what?
3, 4, 5.
Plus 3, right? Is equal to what?
20.
Okay. And what's gonna be, so we already know that, right? And that's 20? So what do these fractions convert to?
15, 20.
9, 15, 20 is and 3, 16, 20.
Whoa.
Yes? Okay. Now what happens next? Okay. And what do I add?
The 9 and 15, 20 is 3 and 16 20?
The 9 and 3 is what? 12. Okay, good. And then the 15 and the 16 is what?
31, 31, 20.
I thought it was 9.
Is equal to 20, right? Okay, so then what do I get here? What do I have to do now?
Subtract. And then the 12 and 31. Swap it around and subtract.
So then what do I do now, Aiden?
And then you minus the 20 with the 15 and
So 20 minus 13 and 11/20 is equal to problem 3, right? So what do I do now?
you minus the 20 with the 15.
But I don't have a fraction, so do I have to borrow?
Yeah.
Okay, so then this turns into 19 and 20/20 minus 13 and 11/20. What does that give me? 13 minus 19 is what? And
9:20.
did we get the same answer?
Yes.
Yes?
Yes.
Okay, but they're asking us to write the answer in minutes, right? So we know our answer is 6 and 9/20. What? How many seconds are in a minute?
60.
So 6 and 9/20 is equivalent to 6 minutes and some seconds over 60, right? So 20 times what gets me to 60? Good. And whatever I'm doing to the denominator, I'm doing to the numerator. So 6 and 9 times 3 is 27. 9 times 3 is what? 27. Good. So then we know that Gavin had 6 minutes and 27 seconds to do problem 3. Yes?
Can we do it like did I just put 6.27?
No. Why?
Because that's how you usually time.
But this is not 100, this is 60.
Oh.
Do we see how we have to,
Yes.
right? So that's the other thing. We're gonna have our end of module. You guys need to make sure we are always paying attention to what we need. Okay?
How did you get the 6 minutes?
Because we converted it. The 6 and 9/20, that was our answer, right? So we had 6 and 9/20, but we know that there's 60 seconds in 1 minute, right? So we know that we need to get to 60. So 20 times what gets me to 60? Good. And then whatever we're doing to the denominator, we're doing to the numerator, right? And this is representative of the minutes. This is the seconds. Yeah? Are we good? Alright. Do we have any questions so far? So do you guys see that we can solve these problems multiple ways, but there's always just one right answer, right? And whatever works better for you guys. I want you guys to do the version that works best for you guys. Yes. Okay, start reading problem 5 for me. Ready? Aiden, you want to read it for us? Go ahead.
Matt wants to shave 2.5 minutes off his 5K race time. After a month of hard training, he managed to lower his overall time from 21 and 1/5 minutes to 19 and 1/4 minutes. By how many more minutes does Matt need to lower his race time?
Okay. So what do we know? What did they tell us, Andrea? Okay, so total shave is 2.5 minutes. Yes? What else did they tell us, Andrea? So his original time was what? Good. And he did, and after a month, was what? Good. 19 and 1/4. Good. And so what we're trying to make sure is that he shaves off a total of what? Okay, good. So then, how do I know, what kind of expression am I gonna set up to find out how much he's already shaved off? Are we gonna add or subtract? Good. Yeah, we're gonna subtract. So what are we gonna subtract?
His original one is 21, 1/5 minus 19 and 1/4 and push.
And that's gonna tell us how much he's already shaved off, right? This is already shaved off. But that's not what we're trying to find, right? Right? We're not trying to find that, right? We're trying to find how much what? More he needs. Okay, good. So then right here, what's gonna be my LCM?
20.
Okay, good. So my LCM is 20. Yeah? So 21 and 1/5 is equivalent to 21 and something over 20. 5 times what gets me to 20?
4.
Good. 5 times 4 at the denominator. We're gonna do the same to the numerator. So that's 21 and 4/20 minus 19 and 1/4 is equivalent to 19 and something over 20. So 4 times what gets me to 20?
5 20.
Whatever I'm doing to the denominator, I'm doing to the 1 times 5 is 19 and 5/20 equals to, okay? Can I subtract this?
Yes.
Yes.
No, yes.
Yes.
You have to
You have to
borrow.
borrow.
We have to borrow. Don't get mad, you guys. You guys get so mad. Okay, and this is 20/20, right? Okay, so then my new equation should read 20 and 24/20 minus 19 and 5/20.
I know the answer.
Okay. So what is my new whole number you're at?
1.
And my fraction?
15. Wait, 20. 9. Wait.
Take a second. 24/20 minus 5/20.
19.
Okay.
Something's going on the computer.
I know it's going crazy. Thank you. So we know that this is how much he's already gotten off, right? But we want a total of what, Andrea?
2 minutes.
Yes. Good. So then what do I have to do now?
Subtract 2 and
Andrea, hold on. Go ahead. What do I have to do now? Because this is not our answer, right? So what are we subtracting? We are subtracting. The what he's already shaved off, right? Okay. Yes.
How'd you get 24/20?
Because I added the 4/20 to the 20/20. Yeah. Do you want me to put it here?
Yeah.
Okay.
Miss Hernandez?
Yes.
What does it mean by how much more minutes does Matt need to lower Matt needs to lower his vertical?
So that's what we're trying to find, right? Because we already know that after 1 month, his time changed, right? So this was his time before he started training, right? And then he trained, and this is the time he shaved off, right? This is what his new time was. So when we find the difference of this, it gave us this, right? So then now, but he still wants, he still is not enough, right? Because that's not what he wants, right? He wants 2.5 minutes. So then, like Andrea said, we now have to subtract 2.5 minutes minus 1 19/20, right? So, how do I convert this fraction?
What 2 times 10, which is 20. So that's gonna give us our.
So 2
LCM?
10/20, right?
Yes.
Minus 1 19/20,
Yes.
right?
Which equals 1 11/20. And then 1 and
We have to borrow, you're right.
oh,
We have to borrow.
also.
So here it comes into what? 1 20/20 plus 10/20 minus 1 19/20, right? So then this is equivalent to 1 30/20 minus 1 19/20, right? So what's my new whole number? I don't have one, right? So 30/20 minus 19/20 is?
11/20. I did have the right answer for the fraction, but I just didn't.
Yes. We miss this part sometimes. Because we're trying to go too fast.
How did you get the 2 1/2?
The 2 1/2 is his total time. The total time he wants to shave off. Yes. So then what do we say? Matt needs to still shave off 11/20 of a minute off his time. Yes?
We're gonna do the exit ticket.
Yes. It's only one problem. Yeah. Do we have any questions? Aiden? Yes, you can go. Yes, we're gonna go over you're gonna work on the exit ticket. I'm gonna give you about, there's only one problem, guys. It shouldn't take us that long. I'm gonna give you about 10 minutes. Okay?
Obviously, with her, Tony and oh, never mind. I see how he's looking apart. Too.
Okay, 20 minutes, 10 minutes to do that one problem. Okay?